At 9:44 p.m., the Red Sea was running 2-meter swells from the northwest, under a sky that offered no moon and no stars, a solid overcast that pressed down to 4,000 feet and turned the horizon into a uniform darkness. The USS Dwight D. Eisenhower was making 14 knots on a southerly heading, 61 miles west of the Yemeni coastline, her flight deck active with the overnight maintenance cycle and the quiet choreography of aircraft being repositioned between sorties. She had been operating in these waters for 7 months. 7 months of daily strike operations against Houthi weapons infrastructure, 7 months of launching F/A-18S against missile storage facilities and radar sites and launch complexes in the mountains north of Sana'a, 7 months of absorbing Houthi anti-ship missile and drone attacks and watching her Aegis screen burn through interceptor inventory at a rate that the Navy's logistics chain was struggling to sustain. The campaign had degraded Houthi capabilities in measurable ways. It had not eliminated them. The Houthi movement had spent 8 years preparing for exactly this kind of sustained attrition campaign, dispersing their weapons inventory across hundreds of individual storage sites, burying their most capable systems in mountain terrain that made targeting difficult and post-strike assessment unreliable. They had absorbed losses that would have ended a conventional military's offensive capacity and kept firing. Their calculation that the cost of sustained air defense, sustained interceptor expenditure, and the political and economic disruption of Red Sea shipping would eventually exceed the American willingness to maintain the campaign, had proven, over 7 months, to be more durable than Washington's planners had originally projected. That calculation changed at 9:44 p.m. At 9:44 p.m., the Houthi Aerospace Force, as the movement had taken to calling the element that managed its missile and drone operations, launched what its commanders had designated as a comprehensive saturation strike. Not a probe, not a harassment volley. The real thing. The strike that had been planned for 11 months as the definitive demonstration that the Houthi movement could impose unacceptable costs on the American naval presence in the Red Sea. 31 anti-ship systems in a single launch window, a mixed salvo of Nasser-1 anti-ship ballistic missiles derived from the Iranian Fateh 110 family, Quds-3 cruise missiles modified from the Iranian Ya Ali design, and a terminal element of Shahed 136 variants pre-programmed for maritime target search. The ballistic missiles provided the speed and the terminal difficulty. The cruise missiles provided the low-altitude sea-skimming profile that stressed different elements of the defensive radar picture. The Shaheds provided the volume, the tail of the strike designed to arrive as the defensive batteries were managing their magazine states after the engagement with the higher priority ballistic and cruise threats. 31 systems, 6 different azimuths, a carefully engineered mix of threat types designed to simultaneously stress every layer of the Eisenhower strike group's defensive architecture. The Houthi strike planners had spent 11 months on the geometry of this attack. They had studied the publicly available information on Aegis engagement capacity, on ESSM reload limitations, on the radar detection horizon disadvantages that sea-skimming cruise missiles exploit. They had incorporated lessons from every previous Red Sea engagement, from the Iranian Houthi cooperative planning sessions that had produced the tactical doctrine for this operation, from the performance data of their own missiles against the Eisenhower's screen. The 31 system salvo was the output of that analysis, the minimum salvo size at which, given the estimated defensive capacity remaining in the Eisenhower Strike Group's VLS inventory after 7 months of intensive operations, the probability of at least one weapon reaching the carrier exceeded 50%. What the Houthi strike planners had not incorporated, because they could not have known, was that the Eisenhower's escort screen had been quietly reinforced 48 hours earlier. The USS Gravely and USS Mason had been in the group since the beginning of the deployment. But 48 hours before the strike, operating under a movement order that had been transmitted in an encrypted message format that Houthi signals intelligence had not penetrated, the USS Leyte Gulf had repositioned from the Gulf of Aden into the Red Sea, adding a fully loaded Ticonderoga-class Aegis cruiser to the strike group's outer defensive ring. Its arrival had not been announced. Its VLS cells were at 100%. The Houthi strike calculation had been performed against an intercept architecture that no longer reflected reality. The Space Force infrared constellation detected the launch signatures at 9:44 p.m. and 12 seconds. 12 seconds after the first Nasser-1 left its mobile launcher on the rocky plateau north of Hodeidah. The warning reached the Eisenhower's Combat Information Center at 9:44 p.m. and 31 seconds. The tactical action officer called the threat count out loud as the tracks populated on the display: 3, 7, 14, 22, 29, and then the final figure as the Shahed launch sequence completed: 31. The commanding officer was on the bridge. He heard the call over the circuit. He did not go to the Combat Information Center. The people in the Combat Information Center did not need him to be there. They needed him to be where he was, making the call that pre-delegated authority allowed him to make without routing through Fleet Forces Command first. He made it in 11 seconds. The Leyte Gulf fired first. Its engagement responsibility was the 5 Nasser-1 ballistic missiles on the highest velocity trajectories, the ones whose terminal phase geometry made them the most difficult for the 2 destroyers to engage from their positions. The Leyte Gulf's SM-2 Block 3B interceptors were optimized for exactly this semi-ballistic terminal threat profile. The first 2 SM-2s left the forward VLS cells at 9:45 p.m. and 4 seconds. Then 4 more. Then the ship shifted to its ESSM launcher for the nearer-range cruise missile threats, beginning to resolve on the radar picture at medium altitude. The Leyte Gulf was doing what a Ticonderoga-class cruiser exists to do, managing a multi-axis, multi-threat engagement with the calm efficiency of a system that has been designed from the keel up for this specific problem. The USS Gravely and USS Mason worked the cruise missile layer. The Cud's 3 sea skimmers were low, 8 to 12 meters above the wave tops at cruise altitude, their radar cross-section reduced by the wave clutter that complicated the fire control solution. The Gravely's SPY-6 radar, more capable than the SPY-1 arrays of the older ships, acquired the first Quds 3 at a range of 41 miles, adequate but not comfortable for the engagement timeline required. The Gravely fired 2 ESSM in shoot-shoot doctrine against the lead cruise missile at 9:45 p.m. and 17 seconds. The Mason took the second and third cruise missiles simultaneously, firing at 9:45 p.m. and 23 seconds. Both ships were working their engagement cues with the speed of crews that had done this, in real combat conditions, for 7 months. The situational awareness in those combat information centers was not the anxious alertness of a first engagement. It was the focused competence of people who had lived in this threat environment long enough that its rhythms were familiar even when the scale was new. The Nasser-1 ballistic missiles were intercepted by the Leyte Gulf's SM-2 salvo beginning at 9:47 p.m. 4 of the 5 were destroyed in their terminal phase at altitudes between 12 and 22,000 feet. The 5th executed a terminal maneuver, a late-phase course correction that the Houthi guidance team had programmed to engage at 8,000 feet, below the optimal SM-2 engagement altitude for a semi-ballistic threat. The Leyte Gulf's tactical action officer had held an ESSM in reserve, specifically for this contingency, recognizing that the Nasser series included guidance variants with terminal maneuver capability. The ESSM engaged the maneuvering Nasser-1 at 9,000 feet. The intercept was confirmed at 9:48 p.m. and 4 seconds. The warhead debris fell into the Red Sea 14 miles from the carrier's last reported position. The cruise missiles were harder and took longer. The Quds 3 sea skimmer had been specifically engineered for this engagement environment. Its low altitude, its wave-following flight profile, and its terminal sprint acceleration from subsonic cruise to supersonic terminal dash combined to make it the weapon in the Houthi arsenal that American defensive planners had spent the most analytical attention on. The Gravely and Mason worked through the cruise missile element methodically, with the Leyte Gulf contributing ESSM fire against the threats that had bled through the outer engagement envelope. 7 of the 11 Quds 3s in the salvo were intercepted in the outer and mid-range engagement zones. 3 were engaged in the inner zone by the Phalanx CIWS systems of the destroyers themselves, 2 of which had closed to within 8 miles of the screen before being destroyed. 1 Quds 3, the one that the Houthi strike planners had positioned at the trailing edge of the cruise missile element, timed to arrive as the defensive systems were managing their engagement sequences, came within 4 miles of the USS Gravely before the ship's own Phalanx system acquired it at 9:51 p.m. and 44 seconds and fired a 3-second burst. The warhead detonated in the Phalanx's round stream. The concussive pressure of the detonation was felt across the Gravely's stern. The blast wave broke 2 porthole covers and rattled the teeth of every person within 100 feet of the ship's stern. The debris, missile airframe components, warhead fragments, pieces of the Phalanx's own expended rounds, fell in a pattern that began 40 meters aft of the ship and extended 160 meters behind it. Nothing struck the Gravely's hull. No personnel were injured. The Shahed tail element arrived at the eastern edge of the engagement zone at 9:52 p.m., 17 minutes after launch, their programmed maritime search patterns activating when their GPS waypoints placed them within the estimated location of the carrier strike group. 12 Shaheds spread across a 4-mile front, their radar altimeters keeping them at 50 feet above the wave tops. The Phalanx systems of all 4 ships in the inner screen engaged simultaneously. The sound of 4 Phalanx systems firing at full rate, 3,000 rounds per minute each, the distinctive sound that crews call the buzzsaw, was audible across the strike group simultaneously. A wall of noise that traveled across the water for miles and was later described by a junior officer on the Eisenhower's bridge as the most physically impressive sound she had heard in 7 months of operations. 9 of the 12 Shaheds were destroyed by gunfire. 2 were knocked down by the Eisenhower's own ram rolling airframe missile launchers, which had been tracking the Shahed element since it entered the inner engagement zone. 1 Shahed, the farthest north in the search pattern, outside the optimal engagement geometry of any ship in the screen at the moment of its terminal dash, impacted the water 230 meters from the Eisenhower's port bow, its warhead detonating in the trough between 2 swells. The explosion sent a column of water 30 meters into the air. No fragment reached the ship. The wave from the explosion was detectable on the Eisenhower's motion sensors as a 0.3 G lateral impulse. On the flight deck, no one fell down.
31 weapons launched. 31 weapons destroyed or detonated in the water. 0 impacts on any American vessel. What the Houthi strike had accomplished was a precise and comprehensive catalog of the strike group's defensive response patterns, its engagement timing, and the specific coverage limitations that the Quds 3 sea skimmer had come closest to exploiting. For a military organization planning its next strike, this would have been valuable intelligence. The Houthi Aerospace Force would not be planning a next strike. The response was already airborne before the last Shahed hit the water. The targeting package for the Houthi missile and drone command infrastructure had been under continuous development for 7 months. Not a targeting package in the sense of a list of facilities identified through imagery and updated periodically. A living document, updated in real time by a fusion of Space Force overhead, signals intelligence, human intelligence reporting, and the post-strike analysis of every previous engagement, incorporating the lessons of each strike and the behavioral patterns of a command organization that had tried, with genuine operational sophistication, to survive in a denied targeting environment.
The package that existed at 9:52 p.m. was not the same document that had existed at the start of the deployment. It was 7 months more accurate, 7 months more comprehensively characterized, 7 months more precisely informed about where the people and the systems and the decision-making actually lived, as opposed to where they were supposed to be. The operation was designated Crimson Silence.
44 F/A-18E and F/A-18F. Super Hornets had been launched from the Eisenhower between 9:31 p.m. and 9:44 p.m., launched before the Houthi strike was detected, on a pre-scheduled strike cycle that had been moved forward by 6 hours, based on signals intelligence collected in the 72 hours prior indicating elevated activity at the primary Houthi command and communications nodes north of Sans. The aircraft were already feet dry over Yemeni territory when the Houthi launch signatures appeared on the Space Force display. They had not known, when they crossed the Yemeni coast, that the strike they were targeting was already in the air behind them. They knew at 9:44 p.m. and 45 seconds when the data link update from the Eisenhower's Combat Information Center reached their aircraft with the message that the group was under saturation attack and that Crimson Silence was now active. The strike lead acknowledged at 9:45 p.m. He pressed north toward the primary target complex. The EA-18G Growlers that accompanied the package had been jamming the Houthi tactical communications network since 9:38 p.m., 6 minutes before the Houthi launch. Not because the launch had been detected, but because the signals intelligence assessment had indicated that the launch was likely within the next 12 hours. And preemptive jamming of the coordination network would degrade the ability to conduct real-time launch coordination across the dispersed battery sites. The jamming had been running for 6 minutes when the Houthi Aerospace Force launched its 31-weapon salvo. That the salvo launch, despite the jamming, reflected the Houthi planners' use of pre-programmed launch sequences that did not require real-time coordination once the sequence was initiated. The jamming had not stopped the launch. What it had done was prevent the launch controllers at each site from receiving real-time feedback on the engagement's progress, from coordinating the reserved follow-on salvo that the Houthi doctrine called for in the event of a successful first wave, and from transmitting the survival order that would have sent the mobile launcher vehicles moving before the response aircraft arrived. The mobile launcher vehicles were still at their firing positions when the F/A-18S arrived on target at 9:58 p.m., 14 minutes after the Houthi launch. 14 minutes was not enough time to displace a large vehicle on mountain roads in complete communications silence. The thermal signatures of the recently fired launchers, hot from the missile exhaust that had burned against their surfaces 20 minutes earlier, were sharply visible on the infrared targeting pods of the incoming F/A-18S, 8 launcher vehicles at 4 separate sites. The GBU-31 JDAM bombs began falling at 9:59 p.m. All 8 vehicles were assessed as total losses of asset by 10:04 p.m. The primary Houthi Aerospace Force command node, the facility from which the saturation strike had been coordinated, a hardened structure built into the western face of a mountain ridge north of Sana'a that had survived 11 previous strike attempts because its approach geometry made accurate bomb delivery from typical attack profiles extremely difficult, was addressed at 10:01 p.m. by 2 AGM-158B JASSM-ER crews. Missiles that had been programmed with a modified approach profile developed specifically for this target's geometry. The standard approach profile for this target placed the weapon on a diving attack angle that the mountain's ridgeline partially masked. The modified profile used a lateral approach that came in from the south, below the ridgeline's masking effect, at an angle that the facility's construction had not been optimized to resist. The first JASSM-ER impacted the facility's primary access corridor at 10:01 p.m. and 14 seconds. The second, arriving 4 seconds later, followed the channel created by the first.
The facility was assessed as rendered inoperable. It would not be assessed as destroyed. The overhead imagery showed the structure still standing after the strike. What the imagery also showed, and what the signal's intelligence confirmed over the following hours, as the absence of the specific emissions patterns that had been associated with the facility's operations for 7 months, was that it was no longer functioning. The people and the systems that had been inside it when the JASSM-ERs arrived were no longer there in any operationally relevant sense. The weapons storage complex in the Marib Highlands, a distributed system of 17 individual caves and hardened storage positions that had served as the primary pre-positioning site for the Houthi Aerospace Force's anti-ship inventory, was addressed by the B-2A Spirit that had been holding in a classified orbit over the Red Sea since 8:30 p.m., its weapons bay carrying GBU-57 massive ordnance penetrators and GBU-31 JDAMs assigned to the 5 most deeply buried storage positions in the complex. The B-2 had been positioned on alert for this target set for 3 weeks, maintained at orbit as a dedicated deep penetration asset for the Houthi bunker infrastructure that conventional aircraft ordnance could not reliably defeat. It had not been used in those 3 weeks because the target characterization had not met the confidence threshold required for employment of the GBU-57. At 9:58 p.m., with the post-strike data from the salvo engagement providing confirmed coordinates for the active storage positions, the ones that had supplied the launched weapons, the confidence threshold was met. The B-2 was cleared hot at 10 p.m. Its weapons fell between 10:14 p.m. and 10:19 p.m. The 5 deeply buried positions were assessed as rendered inoperable. The 12 surface-accessible positions in the complex were addressed simultaneously by a dedicated FA-18 sub-package using GBU-39 small-diameter bombs. The Marib complex, which had been the operational heart of the Houthi anti-ship campaign for 14 months, was assessed as comprehensively neutralized by 10:22 p.m. At 10:47 p.m., the post-strike assessment reached the Eisenhower's commanding officer. He read it standing on the bridge, the Red Sea dark and moving around his ship, the flight deck behind him receiving the returning aircraft from crimson silence, the deck crew moving with the mechanical efficiency of people who have performed this ritual thousands of times and know that the aircraft need to land and the pilots need to be fed, and the mission cycles need to continue regardless of what has just happened. The assessment was thorough. It identified what had been destroyed, what had been damaged, and what the implications were for the Houthi Aerospace Force's future operational capacity. He read it once. He handed it to his executive officer. He looked at the sea for a moment. The Houthi Aerospace Force had spent 11 months planning the strike that had just failed to produce a single impact on an American vessel. It had consumed the majority of its operational anti-ship inventory in the attempt. Its primary command node had been rendered inoperable. Its primary storage complex had been comprehensively neutralized. The mobile launcher fleet, the element that gave the force its survivability and its reach, had been caught stationary and destroyed. What remained of the Houthi Aerospace Force's anti-ship capability was dispersed, disorganized, and severed from the command architecture that had made it operationally coherent. The Red Sea was open, had never been closed to American naval operations, would remain open. 7 months of patience, of absorbing harassment fire, of burning through interceptor inventory while building the targeting picture, had produced this night. Not a coincidence. A plan. The patience had been deliberate, the targeting development had been continuous, and the response that Crimson Silence represented had been ready for weeks, waiting for the Houthi command to make the mistake of committing everything they had in a single night. They had committed. The night had answered. In the mathematics of asymmetric warfare, patience is not a weakness. It is the longest weapon in the arsenal.